Okay, so this time it is actually useful to just go ahead and subtract lambda off the diagonal. And then you remember that an upper triangular matrix is singular if and only if there is a 0 on the diagonal. That leads you to the fact that lambda equals 3 is an eigenvalue here, and so is lambda equal to -1. Once you pick one of these eigenvalues, you then plug that into the equation right here. And if you take lambda equals 3, what you get is 0, 1, 0, -4, and you want to find vectors that satisfy this right here. Okay, and we could of course go and make this into row echelon form, or what we can do is say, well, let's pick chi0 to be 1, and notice that if you then plug that in, and you ask the question, for what value do we satisfy this right here, it is not hard to see that there must be a 0 right here. If, on the other hand, you pick your lambda to be -1, then you end up with the equation 4, 1, 0, 0 times chi0, chi1 equals 0, 0. Now this is in row echelon form. Therefore you pick the free variable to be equal to 1, and you look for vectors of the form 1 something like that. And if you then look at this right here, it's not hard to see that -1/4 works, and what you get are the eigenpairs, let's see, 3, 1, 0, and -1. And the scalar multiple of that is also an eigenvector, and therefore why don't we instead pick -1, 4 for our eigenpair. That's just a nicer vector because it only involves integers. So let's see if we can visualize the eigenvalues and eigenvectors of an upper triangular matrix. We have an upper triangular matrix. The important things to note is that we saw that 1, 0 was an eigenvector, and indeed we have x pointing to the first unit basis vector at this point, which is x0, the first eigenvector. And notice that a times x is, if you look at it, about 3 times the size of x. And looking at the eigenvalue up here, we see that it better be exactly 3 times, because 3 is the eigenvalue associated with this eigenvector, the direction of which x points to. If we then move on, eventually x points in the direction of the second eigenvector. That's the eigenvector associated with the eigenvalue -1. And indeed, a times x should be equal to -1 times x, and a times x points in the opposite direction and looks to be the same length as x. Then we go on, and eventually x points in the direction opposite to the first eigenvector. And again, a times x simply points in the same direction, but is 3 times as long as x is. Okay, so here's a homework where you're asked to identify all of the eigenvalues and eigenvectors of a upper triangular matrix. Go and think about that one for a bit. I'll see you in the next video.